1, we have to state that this is f of x is a polynomial, therefore continuous on 0, 3. Would you accept this first statement?
Yes.
Number 2. The second hypothesis says f of x is differentiable on at least 0, 3. Of course, as a polynomial function. Polynomial function. We know polynomial functions are differentiable and continuous, of course. Continuous and differentiable everywhere. And now I have to test number 3. I don't know if number 3 is okay. I have to find f of 0. So that's item 3, hypothesis 3, and I have to find f of 3. 0, 0, 0, that's 2 for sure. Now for 3, I don't know, 27 minus 9 minus 18 and plus 2. That's, am I correct? 27 minus 9 minus 18 and plus 2. Is this 0? I'm sorry, is this 2? Yes, yes. So then all conditions are fulfilled. So then I will say, then by Rolle's theorem, I will find at least one C in the open interval 0, 3 such that f prime of C is 0. So first I have to find f prime of x, which is, can anyone give us f prime of x quickly? Good. So this was f prime. So now f prime of c equals 0 will mean 3c squared minus 2c minus 6 equals 0. And I find the answer with the quadratic formula. Can anyone guide us through? Anyone? Anyone? Four minus, but this is negative, so plus 4ac 18 over 2a. So now, I'm not sure why my mouse is not working, and this is annoying. Let me check here. Why is my mouse not working? Because I need to switch to, I will not be able to. Do you think the battery is, let me just replace the battery. Maybe that's.
It might just be too far away.
Oh, no, it worked so far. This is annoying. Sorry, I have to use the calculator because I don't want to waste your time. Fix that. So 2 plus the square root of, this is 4 plus 4 times 18, close outside, divided by 6. And then the other one most probably will be negative, so we're not going to use it anyway. Yep. So I got that C equals 1.79 approximately, so C equals approximately negative 1.12, which means that this is not in the interval 0, 3, but this one is. So this is guaranteed by Rolle's theorem.
The camera's still off.
Every time I touch something here, the camera goes off. Sorry about that. Okay, so determine 1.79 in the interval.
You know, it's against your screen.
What is going on? I was thinking about it. Let me just try one more time with all these. Let me see again if it's working. Okay. Good. It will only take a second, but I would rather move on. Okay, so here's our C guaranteed, which means at this point it's guaranteed that the given function has a turning point. In other words, we don't know what it is. It can be max or min, also here, but not in the interval 0, 3. So this is the C guaranteed by Rolle's theorem. Okay, the other theorem is very similar, and it's entitled, the name is the mean value theorem, MVT. Mean value theorem. And here's the scenario for the mean value theorem. Let's say we have a function, and let's say it does this between interval a and b, between on the closed interval a comma b. So this is our f of x, and the first two are the same and are the only ones. So the same hypothesis, like the Rolle's theorem, exactly the same. Number one, f continuous on the interval a comma b, and f differentiable on a comma b, for sure. So now the conclusion, I need my little ruler, and if I touch something, I'm sure it's gonna... Okay, so this is the secant line. Imagine that I got the secant line between going through these 2 points. That's the secant line. And now what I want to do is I want to create a parallel line to the secant line that is the tangent line at any point. In other words, at this point, in this case. So this is the tangent, and this is the secant line. Tangent line, secant line. Okay. So at this point, I definitely have a x-coordinate, and I'm going to call it C. And it is very clear by construction the slope of the secant line will definitely equal the slope of the tangent line. I'm going to call this P, at P. Let's also be very specific. This is AB, so this is the secant line AB. Will have the same slope with the tangent line at P. Is that acceptable so far?
Yep.
Moving on. So, can anyone give us the slope of the secant line? AB.
If we know the points.
Oh yes, we do. We know, of course we do. It's A, f of A, of course. And it's B, f of B. Of course we do. Because we have the interval.
It would be f of b minus f of a all over b minus a.
Thank you very much. So this would be f of b minus f of a divided by b minus a. Perfect. Now, can anyone give us the slope of the tangent line at P? And that's page 3, and this must be page 4. Anyone? Please say it again. Well, what is it?
It would be f prime of x.
Careful. F prime of?
A.
If it's not A, it's not B. There is only one more option, right? Is that clear? Yes? Everyone?
Yeah.
Perfect. So then these two must equal each other because we build them that way. And this is what MVT guarantees. MVT guarantees that there exists a C in the interval a comma b such that this happens, this happens. Okay, so let's look at a question. Let's say f of x equals natural log x, and the interval given to us is 1, 4. The question, like before, says, verify that the function satisfies the hypothesis of the mean value theorem on the given interval. Find all numbers C that satisfy the conclusion of the MVT. Okay, so in number 1, on this interval, it's guaranteed. Remember, we talked about this function many times before. Here's its graph. Natural log x, and this is 1 and this is 4. So obviously the function is continuous and differentiable on 1, 4. So f of x continuous on 1, 4, guaranteed. Number 2, f of x differentiable on 1, 4. Then by MVT there exists C in the open interval 1, 4 such that f prime of C now is not 0 like in Rolle's theorem, but equals f of 4 minus f of 1 over 4 minus 1. Any questions?